Hi folks, this is number 11 from page 110, and in this question here we use a trick that we saw in question in an earlier section. So they're looking for the equation of a line that passes through -5, -4, 2 and intersects this given line at 90 degrees, and then they want us to actually find the point of intersection. Okay, so here, let's draw a picture here. So we've got our given line R. Okay, and we're looking for this perpendicular line, okay, that intersects and passes through the point -5, -4, 2. Okay, now if this was in 2D, it would be a much easier problem because we could just take the direction vector of the line and easily find a perpendicular vector that would be a direction vector for this other line. But in 3D, it doesn't quite work that way because the perpendicular vector to this line might not necessarily be in this direction. It could be sticking out or at some angle outside off the sheet of paper. Okay, so we need to sort of think a little outside the box here. So we're looking for the point of intersection between these two lines. That means that this point lies on both the one we're looking for and the one we're given. So it means that this point here can be written as a point on the given line. In other words, it can be written for some t value as 7 plus t, -13 plus 2t, and 8 minus 2t. Okay, now we know that this given line has a direction vector, I'll call that m1, of 1, 2, -2, and we know that this direction vector would be perpendicular to a direction vector on the other line. Well, we can create a direction vector for this line by joining this point of intersection with the given point. Okay, now I can go in this direction, I can go downwards. I'm going to choose to go downwards here to create my M2. Okay, because I'd like these t's to, I've got two of them, I'd like them to stay positive if at all possible. So I'd like to do this coordinate minus that coordinate. Okay, so let's calculate this vector M2. Okay, so it'll be the x components subtracted. So here we have t and then 7 minus -5, so t plus 12. And then this y component minus that one, so we've got 2t and -13 minus -4, so -13 plus 4 is -9. And then here we have -2t, and then 8 minus 2 is 6, so plus 6. Okay, so this represents the direction vector of the line we're looking for. And so we know that this direction vector must be perpendicular to the vector m1. Okay, so we'll use that to create an equation. So m1 dot m2 have to be equal to 0. So that means that 1, 2, -2 dot t plus 12, 2t minus 9, and -2t plus 6 has to be equal to 0. And let's take the dot product, so 1 times t plus 12, t plus 12. Okay, then 2 times 2t, so that's plus 4t, 2 times -9, minus 18. Then here, -2 times this here, so that would be plus 4t. And then here we've got minus 12. Excuse me, is equal to 0. And we've got an equation, just one unknown, so we can solve that. So here we got t plus 4t plus 4t, that gives us 9t. Okay, this 12 and that 12 goes, so I'm left with minus 18. Bring it to the other side, positive 18. So t has to be equal to 2. But now we know this t value, meaning we have enough information to find the point of intersection that we're looking for, and we also have enough information to find the direction vector for the second line. Okay, so the first thing they ask us is for the equation of the second line, so I'll do that first. So I'll find what m2 is equal to, so let's stick t equals 2 into there. So we've got 2 plus 12 is 14, 2 times 2, 4 minus 5, 4 minus 9 is -5, and then we've got negative 2 times 2, so negative 4 plus 6 is 2. So there's our direction vector. We know that the point negative 5, negative 4, 2 is on the line, so the equation of the line we're looking for, I'll call that R2, is going to be negative 5, negative 4, 2, plus, and I won't use t again, I'll use s, s times the direction vector, 14, negative 5, 2. Okay, and now they also want the point of intersection. Okay, and that's just given now by this set of coordinates here. So we've got t equals 2, so 7 plus 2 is 9. Then negative 13 plus 2 times 2, 4. So that's negative 9. And then 8 minus 2 times 2, so 8 minus 4 is equal to 4. And there we go. We have the equation of the line, and we have the point of intersection. So here it's twice we've seen this trick, that when we've got two lines that are perpendicular, okay, but we only know the equation of one of them, that I can use this point of intersection and the fact that it's on the given line to come up with an expression to represent that point.